Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Shafiqah binti Shafi'i and I will be presenting about Chernobyl disaster. These are the contents of this video, which includes introduction, acute and chronic toxicity, route of exposure, symptom, mechanism of action, conclusion, and references. Chernobyl disaster happened on 26th of April 1986, which is an accident at Reactor 4 Chernobyl power plant occurred during an experiment to test a potential safety emergency core cooling feature, which resulted in 2 workers died on the night of the accident, 28 people died within a few weeks, radiation injuries to over 150,000 people evacuated, 220,000 people relocated, 6,000 cases of thyroid cancer, and large areas were contaminated. It is the world's worst civilian nuclear disaster took place when a reactor exploded at the Chernobyl power plant in Ukraine, then part of the Soviet Union. The Chernobyl nuclear power plant was one of the Soviet Union's most advanced facilities. The first 2 reactors became operational in the late 1970s. The 4th reactor was the newest going online in 1983. On April 26, 1986, technicians prepared to test the backup cooling system in reactor number 4, but the routine safety drill went horribly wrong. A nuclear reactor is like a giant steam engine. Uranium fuel rods react to produce a massive amount of heat that converts water into steam, which drives huge turbines to generate electricity. Control rods are inserted in between the uranium to slow the reaction, and it's crucial for cooling water to be pumped around the core to prevent overheating. But as the test began, almost all of the control rods were removed and technicians lost control of the flow of coolant. Temperature soared and extreme heat began to melt the core. At 1:23 a.m., Reactor 4 exploded. It spewed 8 tons of radioactive debris into the atmosphere. The disaster resulted in high acute levels of radiation exposure. High doses of radiation over short periods of time produce acute short-term effects. High doses of radiation tend to kill cells. This damages tissues and organs. All of this can lead to a whole body response called acute radiation syndrome, ARS. A total of 134 Chernobyl emergency workers were verified with ARS, with 28 died within the first 4 months. Figure 1 shows the outcome for patients with ARS. Skin doses exceeded bone marrow doses by a factor of 10 to 30, and many ARS patients received skin doses in the range of 400 to 500 gray. Radiation damage to the skin aggravated other conditions. Radiation burns to the skin were felt to be a major contributor to at least 19 of the deaths and significantly increased the severity of the ARS, especially when skin burns exceeded 50% of the body surface area and led to major infections. Next is chronic toxicity. Low doses of radiation over long periods of time can produce chronic or long-term effects. Low doses do not tend to cause immediate problems to tissues and organs, but over the long term, they can damage or alter the genetic code, which is known as DNA mutations. This damage can happen in both gametes and somatic cells. Gametes are reproductive cells. DNA mutations in gametes can be inherited by children. These children might grow or develop at slower rates. Somatic cells are non-reproductive cells. Mutations in somatic cells can cause cancer. Many of the patients who suffered moderate or severe ARS developed radiation-induced cataracts in the first few years after the accident. Clinically significant cataracts developed in some of the ARS survivors exposed to high radiation doses. Several new studies have suggested that lens opacity may form after doses of less than 1 gray. A substantial increase in thyroid cancer incidence has occurred in the 3 republics, which are the whole of Belarus and Ukraine, and the 4 most affected regions of the Russian Federation since the Chernobyl accident among those exposed as children or adolescents. Among those under age 14 years in 1986, 5,127 cases, and under age 18 years in 1986, 6,848 cases of thyroid cancer were reported between 1991 and 2005. The last one is leukemia. The interest in leukemia arises because of its non-sensitivity to induction by ionizing radiation and also because of the short latent period expected between exposure and appearance of the condition. Although not conclusive, recent reports suggest an increase in the incidence of leukemia among the recovery operation workers from Belarus, the Russian Federation, Ukraine, and the Baltic countries. Next is the route of exposure. There are two routes of exposure of radiation, which are through gastrointestinal tract and respiratory tract. Through gastrointestinal tract, it is an environmental exposure to food and water contaminants. Meanwhile, through respiratory tract, it is an exposure to air contaminants. Next is symptom. Depending on the dose levels, major manifestations of ARS include signs of hematopoietic depression with concurrent infection and hemorrhage. The intestinal, toxemia, and cerebral syndromes occur after large doses with signs of diarrhea, water loss, fever, arterial blood pressure drop, and changes of function and structure of the brain. Occasionally, with very high acute doses to the head or trunk, there may be loss of consciousness, which is sometimes referred to as transient incapacitation syndrome. Next is the mechanism of action of radiation. Radioactive elements such as uranium and barium release excess energy in the form of particles or waves. Alpha particles, beta particles, and gamma rays are types of radioactive emissions that can cause damage by interacting with the atoms that make up living cells. All types of radiation can cause damage to the body and lead to a condition known as radiation sickness. When radioactive particles or waves interact with atoms in your body, they can knock off electrons that orbit the nucleus of that atom. This changes the way an atom normally functions and forms ions, also known as free radicals. These ions have abnormal reactions with other atoms, such as the ones in the cell's genetic material, leading to mutations and possibly cancer. Exposure to high levels of radiation may lead to cell death and consequently tissue or organ failure. A weakened immune system, often a sign of radiation sickness, results in increased number of infections. Next, let's watch some effects of Chernobyl disaster. The accident at the Chernobyl nuclear power plant in 1986 was a tragic event for its victims. Although those exposed as children and the emergency and recovery workers are at increased risk of radiation-induced effects, the vast majority of the population did not live in fear of serious health consequences due to the radiation from the Chernobyl accident. Lives have been seriously disrupted by the Chernobyl accident, but from the radiological point of view, generally positive prospects for the future health of most individuals should prevail. These are the list of references used in this video. That's all from me. Thank you for watching.